Okay, we're going to go through 3.5 and kind of do this in 2 days. So we're going to be trying to find equations for perpendicular bisectors, which is something that we've already been doing in calculus. So I've got, these are the homework problems for you to do after I'm going to go through 2 investigations. So this is GeoGebra. We've got a line segment. So write an equation for the perpendicular bisector of AB. So in order to get the perpendicular bisector, I can use this perpendicular bisector tool and just click right there. And we notice that it goes right through the midpoint. So if you're doing this by hand, that's the first thing we need to find is the midpoint. And GeoGebra can tell us these coordinates, but you should have to find these just by using the endpoints of A and B, which are given. So the x-coordinate would be, you just take the x-coordinate of A plus the x-coordinate of B divided by 2. And then, oops, I don't want parentheses yet. And then the y-coordinate, just take this y-coordinate plus this y-coordinate, 6 plus 2 divided by 2 to get the middle. So this point is -2, 8 divided by 2 is 4. So that's how you get the midpoint. Okay, and then to get the equation of this line, we need to find the slope. But we don't have another point on this line. So the way we're going to have to do that is find the slope of AB. Okay, and then take the negative reciprocal, like we learned in calculus. So the slope of AB, just take the y-coordinates, so y1 minus y2, and x1 minus x2. So it doesn't matter which one you call. I'm going to call this the first point and this the second point. So x's go on the bottom, -8 minus 4, and y's go on the top. So this equals 4 over -12, which is -1/3. That's the slope of this line, AB, or segment. So then we want the negative reciprocal, which would be +3, since this is already negative. So the slope of the perpendicular bisector would be +3, right? Because this line's going from left to right uphill. So then we take our slope and our midpoint, and we have to figure out what this y-intercept is, which I can see is 10. But you're not going to be able to see that when you're doing this by hand. So I'm going to have to set up my equation, y equals mx plus c, plug in the slope for m, and plug in the midpoint as the x and y coordinate, because that's the only point we know on this line. So x is -2, c is the y-intercept, and 4 is y. So we have 4 equals 3 times 2 is -6, add 6 to the other side, and we can see it's 10. So now we write out the equation of the perpendicular bisector, y equals 3x plus 10, and we're done. So then I'm going to go to now I'm going to go to the second investigation, finding the coordinates of the circumcenter. So here we have a triangle, and the circumcenter is the point that is equidistant from the 3 vertices. And this is going to become important in the next section that we do. So I'm just going to show you, if we find the perpendicular bisectors and we see where they cross, that is called the circumcenter, which if I take my compass tool and I click here, you can see that this is called the circumscribed circle. It goes around the triangle and it goes through all 3 vertices, which means this point right here is the same distance away from each vertex, because these are the radii of the circle. So what you need to figure out by hand, if you've got a triangle, is find two of the perpendicular bisectors and just see where they cross. So I'm going to get rid of this circle, and we only need two of these perpendicular bisectors, so I'm going to get rid of one of them. So this is really all we need to find this intersection point. And GeoGebra can tell us, what these coordinates are, so we know what we're looking for. Negative 1.5 and 4.1, which is probably being rounded. So how do we now we just need to do what we did in investigation 1. We need to do it twice. So get the equation of both of these lines and then set them equal to each other to see where they cross. So I need to find this midpoint by taking x1 plus x2, so negative 5 plus 9. Negative 5 plus 9 divided by 2. That's the x-coordinate of the midpoint. And then take the y-coordinates, 8 plus 4 divided by 2. So this is 4 over 2, which is 2. This is 12 over 2, which is 6. So this point is 2, 6. Okay, might as well find this midpoint too, since, well, let's focus on this line instead. Because now we need to find the slope of this perpendicular line. This is going to be a right angle, but we need to use the slope of AB in order to get that. So slope of AB is, y's go on the top, so 8 minus 4, right? 8 minus 4, and then negative 5 minus 9. So this is going to be 4 over negative 14, which is negative 2 over 7. So then the slope of our perpendicular bisector is going to be the opposite reciprocal, which is 7 over 2. Okay, and then we plug in what we know into our equation. Y is going to be 6, M is 7 over 2, X is 2, and we need to find the y-intercept. So these twos are going to cancel out. We get 6 equals 7 plus C, subtract 7 on both sides. The y-intercept is negative 1 down here. So our equation for this perpendicular bisector is going to be y equals 7 halves x minus 1. So that's the first one we're going to need. Now this perpendicular bisector, we just do the same exact thing. Here's the midpoint. Take the x plus the x, so negative 5 plus negative 3 divided by 2. Then take the y-coordinates, 8 plus negative 2, which is 8 plus negative 2 is the same thing as 8 minus 2 divided by 2. So then the coordinates of that midpoint are negative 8 over 2, which is negative 4, and 6 over 2, which is 3. Okay, and then we find the slope of AC. So x is on the bottom, negative 5 minus negative 3 is going to be plus 3, and 8 minus negative 2 is going to be 8 plus 2. So this slope is 10 over negative 2, which is negative 5. But then we want the slope of the perpendicular, so we take the opposite reciprocal, so that's going to be positive 1/5. And then we take this stuff and plug it into our equation. The y-coordinate is 3, slope is 1/5, x-coordinate is negative 4, plus c to figure out what the y-intercept is, what this point is. It looks like it's going to be a fraction. So this is going to be negative 4/5, which is negative 0.8. Then we add that to the other side and we get 3.8 equals c. Looks like about 3.8. Seems reasonable. So then our equation for this perpendicular bisector is y equals 1/5 x plus 3.8. Okay. And now, to find the coordinates of this point, we can solve it algebraically by setting these equal to each other. Or you can graph it on your graphing calculator. So I'm going to do that. I'm going to get my graphing calculator. Okay. And just type in both equations. So y equals 7 over 2 x minus 1, and 1/5 times x plus 3.8. I'm going to say zoom 6 and see where they cross. Remember, we just do second, calc, intersect. First curve, just make sure I'm on the first line. Second curve, it jumps to the second line. And now guess I need to go over to the intersection. And I got 1.45, comma, I'm going to do 3 sig figs, 4.09. 4.09, which is why GeoGebra rounded to the nearest tenth. So that's how you do it.